the years, GE have developed many applications for the automation platform. Well, the application that we are interested in today is the data translation application, or DTA. The DTA has been developed for many platforms, for example, the D20M, M++, M+, ME, ME2, MX, D200, D25, iBox, and the iBox kit. And in all of these platforms, more or less the DTA would do the same job. Some DTAs were developed for specific platforms, for a specific customer, and carry the customer name. Some DTAs were developed across all the platforms, so it works in the iBox, in the D25, in the D200, in the D20. Some applications were very generic, some of them very specific to the industry. So for example, some of the generic applications that we give to every customer who purchase a D20 system or a D25 or an iBox is the calculator application, A083. And it's a very useful application, very powerful. You can build logic in it. You can build very complex logic in it. I've seen customers with building something that as complex as a requirement for a ladder logic inside calculator. Also, we've got the ProLogic and the Logic Links application, which were developed over the year to allow customers to program using IEC standard programming languages, and that allowed the customers to put ladder logic functional diagrams inside the D20. The D20 is a very powerful box that allow you for execution of these of that logic. So what happened is customers would find a certain logic to be useful in the field, but they require it to be executing efficiently and not via the interpretation of the ladder logic. So they would approach GE in order for us to create a specific DTA for their industry sector. GE would evaluate it, and if we found it that it is common to a lot of customer base, we would have developed this DTA. Now, what you have to know as a user of the remote terminal unit is that if you're thinking of a certain application or a certain logic, let's say you want to OR all your digital inputs, we could have a DTA that will service your need. For example, Common Alarm DTA, Data Translation Application. And the Common Alarm DTA will allow you to take a whole bunch of digital inputs and change them into a single alarm point. All right? There is many applications that serve the generic need, and there is applications, like we said, that serves the specific need. So for example, there is also the substation maintenance application, which means that you turn this on and then no alarms will be transmitted to your operators while maintenance is taking place, right? So you don't want false alarms at your operators. Okay, so now hopefully you have an understanding that these applications exist in not in all the platforms, in some of the platforms, and some of the applications are generic, so they have a generic application. Some of them are very specific. So I'll try to demonstrate throughout this discussion that the specific one that are useful per industrial sector. The information would be created in the field as digital information from a sensor or a meter that's measuring something, or a relay that's taking certain important action, or from a peripheral like an I/O card that is connected to these sensors or inputs from the field. Once the information is available in the field, it's then formatted in a protocol and transmitted to the physical port that it is connected to. That physical port could be either a serial port or a network port. There is an application that's constantly monitoring that port for information that is of interest, which is the data collection application family of protocols. So it could be either a DMP data collection application, or a Modbus data collection application, or a 101 data collection application. The data collection application would take that information that is received from the physical port, decipher it, figure out the important information that needs to be stored in the WIN database, places that information in the WIN database. Now what we have inside our WIN database is physical data that we received from the field. That information would then be pulled out by a data processing application. The data processing application would format the information in order to send a reply. The reply will go to the communication port, the target physical port that is connected to a master. The master would receive this information that's of interest and then present it to an operator. One thing to note here is that if the information that's received from the field inside the WIN is not the information that the master wants to view, or the master requires that information to be manipulated or changed, then that is where the DTA come into play. The DTA picks up the physical information, change it, manipulate that information, and then put it back into the WIN database, right? The DTA has other strengths where it can monitor the communication. So it can monitor the communication between a data collection application and an IED, and whenever it sees no activity or there is a drop of a certain RS-232 signal, it can raise a digital input point or an alarm. So in this case, it's putting information not about physical information that was received in the field, but behavioral information that will talk about certain status that took place in the remote terminal unit. It can also pick up information or make information available to masters so that masters can behave or issue commands as required. So for example, it can stop or lock a master from sending a digital output to the field if that master doesn't have control of that digital output on the field, and I will elaborate on these applications.